Hello, all right, hello everybody, and welcome to a new open class. So today we are going to continue with our latest topic, which was related to ChatGPT, but we are going to change a little bit the point of view. More than for creating code, we are going to be reviewing some of the codes that our participants created for the FastBot Racing Contest that has been held during this summer. You can see, besides me, some videos of the FastBot Racing Contest. So, yeah, hello everybody. First of all, as always, please let me know if the sound is fine, if the video is fine, if everything is good so that we can continue without any other problem. So let me know here in the chat, please, if everything is good. All good, says Yuhon, also Karim, all good, all good. Video is good. Sound could be louder. Okay. You know that you can increase the volume here, also in the stream itself. There is one of the buttons that allows you to increase the volume in case it's a bit low. Here from my side, it looks fine, at least. So yeah, what about the others? Do you hear me low? Do you hear me just okay? Good, says Rajesh. Okay, so somebody says that they can hear me fine, somebody says low, okay. So I'm going to try to just put it a bit louder from here. It's almost at the maximum, so yeah. Gilbert says that I'm just a deaf almost. Okay. Yeah, I will try to stay here close to the mic so that everybody can hear me fine. All right, then. Okay, so yeah, then let's get started. So as the title of today's class says, so today what we are going to be doing is a bit of a live code review session, okay? And for that we are going to use ChatGPT to make the process much faster and smoother, okay? And then what code are we going to be reviewing? Well, we are going to be reviewing some of the codes that the students sent to us for this FastBot Racing contest, okay? My colleague Ricardo last week already did the ceremony for testing the fastest codes, the fastest participants, right? And he already announced the winner and everything. But we had many other people that sent us code, and there are some of them which are very interesting. So I would like to, during today's session, review a couple of them. I have seen around there Rajesh. So one of the codes that we will be reviewing today is his code, which, by the way, it was an amazing job. And I think it deserves to be shown. So yeah, basically that's what we are going to be today. It's going to be a bit of an improvised class. So basically I'm going to be checking this student's code and asking ChatGPT to basically help me analyze what is the methodology that they have used, what are the most important parts of their codes, etc. So yeah, then let's basically get started. So for that, I'm going to start by sharing here my screen. There we go. Here I have the chat with all of you. And also let me actually tell you something, because I also saw my colleague Yuhon there around the chat. So for today's class, I would like to do also something special. So lately, you might be aware, or you might not, I don't know, that we have actually launched an updated version of our platform. Okay, this is the Construct platform that probably most of you are familiar with from the last months, years even. Yeah. So now we have launched an updated version, as you can see from the banner here, that a new version is available. Okay. Then maybe some of you have already tried this version, maybe some of you don't, but I encourage you to do it because it's really, really amazing. Okay. And in fact, I'm going to switch right now to that version. So let me click myself here and let me move to the new version right here. You can see this desktop feeling, right, which I really love it. And let me move then to the open classes. Here I should see all of you. There we go. Okay, I still have all of you here, and in case that you switch to this new platform, you are going to be able to find the open class as always in the here in the Learn button, right? Here, and just go to open classes and you are going to be redirected here to the current class. Okay, and then nothing changes. So if you are familiar with our last open classes, all you have to do is to click on the fork and open the class ROSJECT. Okay, this is the very next step in order that in order to get today's class ROSJECT. Okay, so I'm going to do that myself here, and let me launch the project for today's class. And there we go. Okay, so here I'm in the new platform. Then let me see if I can manage to hide the streaming panel. Is that a thing I can do here from my side? I'm not very familiar actually with this new platform, so maybe there are some things that are going to be strange. Harsh says, please zoom out. Ah, okay. Yeah, there we go. Okay, there we go, there we go. All right, okay, so somebody was saying, by the way, that the audio was too high, right? So in order for mute the simulation sound, all you have to do is to click on the simulation window, which is right here, and then press the T key in your simulation, okay? That is going to completely mute your simulation, okay? And let me, by the way, open here another window, or maybe I can do it from here directly. Let's see, so that I can go to open class and have the chat somewhere around here. Yeah, this is great. Okay. So yeah, basically what you should all have is something like this at the end. Okay, this is the ROSJECT page with the simulation. In case that you want to mute the simulation, let me repeat that. Just press on the simulation window and press the T key in your keyboard, okay? That is going to basically activate or deactivate the sound in the simulation, okay? Yeah? Are we good? Is everybody good? Are you guys following? Everybody is inside the ROSJECT? Yes, no? Any issues so far? Karim says works. Okay, excellent. What about the others? Everybody is ready with their ROSJECT? Yes, no? Okay. So if no one, Gilbert says yes. It's loading for Alex. Okay, perfectly fine. It shouldn't take. It should just take some seconds. So you will be here with us in a moment, Alex. No problem. Okay, then let's get started. So yeah, then here I am my ROSJECT. So let me make a bit bigger the notebook so that we can proceed for now. So yeah, basically this is the same simulation that we have been using lately. So there is nothing strange with this simulation, okay? It's going to be automatically opened as soon as you enter the ROSJECT, as you will see. All right, you can obviously make it bigger, smaller, whatever you want. And in case that your robot fails off the racing track or whatever, no problem. You can just restart the simulation by clicking here on the reload button, okay? That is going to relaunch the simulation and reset it to its initial state within a few seconds, okay? There you go, mine is being restarted here. Okay, and then you still have here in the ROSJECT some indications about how to control the simulation. Okay, just down here you can obviously interact with it using RVs, check the simulation topics, okay, and all that. But basically for quick interaction, you have here also some indications, like for example the T key, as I was explaining, to switch on off the simulation sound. Use the arrow keys from your keyboard. I'm going to do that right now in order to basically teleoperate the robot. Okay, so you can move it around by just using your keyboard and obviously having the focus on your simulation window. Okay, and obviously because we are working with ROS, right, you are going to also be able to interact with the simulation from the terminal, yeah? So if you type a ROS topic list, you are going to have access to all the simulation topics. And for example, you can obviously use as well the teleoperation twist keyboard command in order to teleoperate the robot using directly ROS, okay, as I am doing right now, okay? Nothing new so far. And also the main goal of today's class is not to interact with robot, but to analyze some code. But I think it's good to give you some hints in case that there is anybody new to these open classes, right? So that you can play a little bit around with robot and do your own testing. All right? Okay. Then, yeah, also remind all of you that this robot, the robot that you are interacting here in the simulation with, which is the FastBot robot, can be, you can get one. It's a very interesting robot because it's very affordable, right? And it's easy to assemble, and it's going to allow you to work on your own robotics projects, to test several things. It comes with different sensors, such as a LiDAR sensor, a camera sensor, so that you can test navigation, yeah, autonomous navigation. You can test robotics perception, for example. So it allows you to work on your own projects, or to even to use it for teaching and for creating learning material. Okay, so you have also the link here for the robot. In case that you are interested, just click here on the by the FastBot robot, and you are going to get redirected to the page where you can get much more information related to the robot. And even play with the simulation here, which is super interesting. So yeah, here you have all the information in case that you are interested on acquiring one of these FastBot robots, okay? The real version. So here we have the simulated version, but we also have the real version of this robot that you can assemble and use for real robotics projects. All right. Then, with all the proper introductions made, let me go back very quickly to the chat to see if everybody is good. Okay, so yeah, nobody is reporting any problem, so I'm going to assume that everybody is good and we are ready to get started. Okay. Then, so today we are going to continue with the ChatGPT theme, all right? In previous classes, we were basically reviewing how we can use ChatGPT basically to optimize, right, how we create robotics code. Yeah, in case that you missed those classes, you can come here to past classes and you are going to be able to review them, all right, and get the ROSJECT for those past classes and review the notebooks and work with the code, okay? So, let me see. Let me open this again. Here. Okay, this is not loading right now, but no worries. You are going to be able to find past classes here as well. Okay. So, what if I change here? Classes. Okay. Let me try to maybe. Okay. Yeah, here I cannot see the class, but no worries. Okay. So let me just, for some reason, for me it's not opening here, but never mind. It's not important. You can catch up with past classes whenever you want, okay? Then the focus for today's class is going to be actually to use ChatGPT for something different, which is for analyzing somebody else's code, okay? This is something that it's very common as roboticists, right? We find ourselves having to use external packages that somebody else has created, external frameworks, use APIs, right? That we are not familiar with. Then for those scenarios, ChatGPT can also be very helpful in order to help us get familiar and understand external code much faster and much more effectively, okay? And that is going to be what we are going to be basically focusing on today, all right? So here you can still find some of the things that I was explaining for previous classes, because I think that they are probably still relevant for today, all right? So, for example, some of the hints that we have already covered in previous classes are to be clear about your goal, okay? This, of course, also applies to today's class, okay? I'm going to get more specific in today's topic in a moment. Provide context when possible. Yeah, this is another of the hints that we were reviewing when we were creating code, robotics-related code. Be iterative, okay? Which was to treat ChatGPT like a conversation, okay? And ask for explanation or used code, okay? These were some of the hints that we were covering in past classes, and you are going to see that basically for analyzing code, more or less it follows the same guidelines, okay? So here in step 3, it gets much more, we get much more specific on code analysis, okay? So what about code analysis? What if we want to use ChatGPT to understand robotics-related code you are unfamiliar with, okay? Then here you have some hints for this specific scenario, which is the one that we are going to be focusing on today, all right? So I'm going to minimize the simulation for now, and let me make this a bit bigger here. So okay, so let me move down. There we go. So give ChatGPT the right context, okay? Very important. For example, is ChatGPT going to analyze ROS2 or ROS1 nodes, okay? This kind of information is very important if we want to get better results, okay? Or is, are we going to analyze URDF chakra files instead of actually C++ or Python files, for example? Are we going to be analyzing launch files instead? Is this some code for control algorithms or motion planning logic? Yeah. So always it's good to provide as much context as possible to ChatGPT. Okay. This goes in the line also of provide context when possible. Okay. See. So the idea is more or less the same. Yeah. In any scenario, it is always good if you want to optimize the ChatGPT responses to provide context, okay? In this case, provide context about the code that you want to analyze. Is it ROS1? Is it ROS2? Is it a launch file? Is it C++? Is it Python, for example? Yeah? So, very important point. Yeah, give the right context. Now, point number 2 is break it down for analysis, okay? So this is especially relevant when you are dealing with large code. We are going to see some examples today that the codes are pretty big, okay? So this point number 2 is going to apply, yeah? Basically, if you paste large, for example, large pieces of code or a whole repository, right? Because this is something that you can do. You can paste to ChatGPT a repository URL, right? In order to analyze it for you, yeah? Then that at some, in some cases, that might be just too much for ChatGPT, okay? So the general idea is to always try to go from top, high level, to the bottom, low level, okay? Yeah. So as you can see here, start with the highest level and drill down, okay? And here you have a more specific example so that we can understand this better. So for example, our first question would be, this is the main ROS2 node. Can you summarize what this node does at a high level? Okay. That is a very good first initial question so that we can understand on a high level what the code we want to analyze is doing, okay? And once we have the high-level understanding, we can get more specific, yeah? So, for example, a follow-up question would be, now explain the role of trajectory callback function in detail, yeah? So, now that we have the high-level understanding, okay, now give me the details about this specific function, because I'm interested in this specific function, okay? Yeah? Or for example, what does the control loop do? And how does it interact with the PID gains? Okay, these would be good follow-up questions after having an initial high-level idea of what the code that we want to analyze does. Okay, this is what we are going to be applying today in order to analyze some of the codes. All right. Now, tip or hint number 3 is to use targeted analysis prompts. Yeah, so these are some useful prompt templates for understanding unfamiliar robotics code. Some examples. For example, for a high-level overview, it would be explain what this code does as if I'm new to this robotics project, for example. Yeah. For a flow analysis question, so summarize the main execution flow of this ROS2 node from startup until shutdown. Yeah. For component interaction, so describe how the motion planner interacts with the sensor manager in this code. Yeah. So these are just some examples of prompts that you can use. Yeah. For example, for function breakdown as well. Step through this function line by line, explaining the purpose of each major statement. Okay. So some good examples of targeted analysis prompt for achieving different results, yeah? If you want a high level, if you want a flow analysis of the code, if you want a specific function breakdown, yeah? So you have to use different prompts for depending on what is your goal, what you want to achieve, okay? Number 4, ask for visual aids, yeah? So ChatGPT can also provide you with flowcharts, for example, yeah? ROS graph diagrams to see how nodes interact, how topics interact, etc. It can even create some images, yeah, in order to help you better understand a specific concept. Yeah. So you have also the possibility to ask for visual aids in order to better understand something. Okay. And finally, or almost finally, would be hint number 4 for using iterative learning. Okay. This is similar to what we already explained earlier, which is going from high level to low level. Yeah. But basically, the best way to understand unfamiliar robotics code is to work in layers. Okay. Yeah. So what does this mean? That you should always start with the big picture. Okay, big picture is basically the same as high level understanding. Okay, you should always start with the big picture and then zoom into components. Okay, so once you have the big picture, you can start asking about more specific functions of the code or specific sections, components of the code. Yeah, so start from a big picture and then zoom in into what you are interested. Okay. Also ask out specific algorithms or math formulas. Okay. And finally, point number 4, which is related to tip number 6, would be to cross-check with ROS or simulator documentation. Okay. What does this mean? This means that you should, okay, verify with external documentation. Okay. This means that, yeah, ChatGPT can help you understand faster, yeah, how a specific code ROS to node works, okay? But it can miss some specific information, okay? Or it can even be wrong at some very specific knowledge pieces, okay? So it would be a good practice also to, in case that there is something that you have doubts about, okay, to always cross-check the information with external documentation, okay? Yeah? Yeah? Does it make sense? What I have explained it right now, yeah? Let me have a quick look at the chat here. Karim is saying the live stream is not lagging for me. Had a few short audio cutouts. Okay. Is it working fine now? So is everything clear, guys? So far, can we move on? Yes, no? Let me know here in the chat. It's good from my side, says Yuhon. Okay. It is fine, says Anderson also. Okay. Let me see if I can open now the open classes here. No, not yet. For some reason, this is like bugged here in my computer. But well, never mind. I can still read you all here. Okay, so I would assume then that everything is fine. So let's continue. Okay, so now we are going to get into a bit of practice. Okay, so we are going to actually start reviewing some code. Okay, so let me very quickly show here the final list. Let's see if I can have it. It's this one here. Racers. No. Sorry. Here it is. Okay, this is what I was looking for. Yeah. So this is the total time ranking, the final ranking that we had for our robot racing contest. All right. So yeah, let me get in here. Okay. So yeah, Emil Novak won, and you can see a bunch of participants. basically 7 that had different times, but from all of these participants, I have selected a couple of them that I found their codes very interesting. So that's the ones that we are going to be analyzing today with the help of ChatGPT. And those ones are the codes from Rajesh, which I saw he was around there in the chat, and also from Nicolas Betancourt, okay? So they are right after the top 3, yeah, they are in position 4 and 5. So those are the codes that I would like to be analyzing today. So let's just start, for example, with Nicolas, which it's going to be a bit faster to analyze. And then we will continue with Rajesh, which actually is a much more complex code or series of codes, okay? All right, so let me start then by uploading here. Let me open this in a different window, and I'm going to take it out from here. So here I'm going to be, let me upload right now. I have prepared the files here in my local computer so that I can upload them quickly. There we go. And then here I need to basically analyze just uncompress real quick here the code from Nico. So FastBot Racing, and then I'm going to move the FastBot Racing Nico.tar to FastBot Racing. There we go. Then let me get inside here, uncompress the code. And just build it. So colcon build. There we go. Source and launch, okay? So for this, you are not going to be able to upload the code yourself, obviously, because you don't have it, and because it's not our code, I didn't want to put it directly in the project for everybody to see what they have done, in case that they want to share it, so no problem from my side, okay? But in this case, I'm going to be putting their code here in my project, executing it to see a little bit how it performs, and then analyzing it afterwards, okay? So, yeah, then basically this is ready, so the only step missing would be to launch it with the command, which is it's ROS to launch FastBot Racing and start racing. I think it was the launch file. Yes. Of course, I need to open the simulation. Let me restart it so that we have a proper simulation here. Okay, I'm going to mute it. And let me execute the code. There we go. Okay, so let's see what we get here. So we can see it's already doing some stuff, and the driver has basically started, and automatically it has opened here the graphical tools, probably for visualizing some kind of information, right? So let's see what we have here. There we go. So here we can see, we can get a first idea, visual idea of what this code is doing, okay? So this is basically the camera output, yes, the information that the robot's camera is capturing live, okay? There was a small problem there, okay, and this is something that sometimes it happened, okay, for this specific participant. Let me try to, I can try, for example, to run everything again. But basically you got an idea, okay? I'm going to start it one more time so that we can see it again in action. T, and let's launch it. Let me change here the camera. Oh, sorry. I thought I was, okay, let me show this again. I'm sorry. So, okay, now you can see my screen, right? Yeah, my bad. I completely forgot I was in the ranking window. So now you should be able to see my screen. Okay. Apologies, my apologies. Yeah, so basically what I have done is just to upload Nico's code here to the ROSJECT, and I am executing it, okay? So let me do that right now. There we go. This is Nico's code being executed, and you can see here how the robot starts moving. Okay. And what I was saying is that the graphical tools automatically pop up, and this shows us, gives us an idea of what this code is doing, okay? So we can see here the output from the robot's camera, and here there is some kind of polygons, which I would guess they are kind of, it seems like they are following the lines, right? We can see here like some crosses that more or less are following the track lines, yes? So it seems like Nikos has created some kind of line following, yeah? He's using the camera to detect the this white lines pattern in the center of the track, and he's making the robot follow these lines, right? Just from having a look at what we have here, yeah, we could guess that something like this is happening, okay? Now here there is a change in the lines, but still the robot is able to continue following this yellow line pattern, okay? And the robot continues here following the white lines. It's turning pretty well, I must say, okay? Let's see these final turns until it reaches the finish line. There it's going. And there it is, almost reaching the final lane, and there we go, okay? The robot is going to continue, but let's, we are going to stop it here, okay? All right, so very cool, very interesting idea, but now, what I would like to do is to actually analyze this code, okay? So this is the package that Nico created, okay? So let's have a look at the code, okay? Then the launch file that we are executing is start racing, by the way, so we can have just a quick look at this launch file, and with this information we can very clearly see that the executable that is being started is this simple driver, okay? And for example, if we go to the setup.py, we can see that the simple driver is this, it corresponds to a Python script named also simple driver, which is inside FastBot Racing, yeah? So basically the code that we have just run is this one here, okay? So, yeah, so we could just start going line by line over this code and trying to understand what's going on, okay? We could do that. It's not a super large code, as you can see, okay? It's 244 lines, okay? So it wouldn't be something super complicated, but we can use ChatGPT in order to make it much easier for us, right? And that's what we are going to do. Okay, then let me open again the notebook. So following our the tips that we have just introduced for analyzing code with the help of ChatGPT, what is the first thing that we should do? What should be the first step? Well, it should be to go for the big picture, right? Let me close the simulation for now, yeah? So I want to get a big picture of what's going on in that program, okay? So this is an example super prompt that I have shared here that can help you use different approaches for having this big picture, okay? So this is like a super template, okay, that you can use if you want in order to go over this first step, okay? And this example prompt goes as follows. So you are an expert in robotic software, and here I am providing some specifications of techniques, okay? Give me a concise but clear analysis of this code, okay? The code would be down here, right? And then here there are some points that we can ask ChatGPT to clarify for us. Like, for example, the purpose. What is the purpose of this code? General purpose. ROS context, for example, yeah? So what are the topics, services that this code is using? Yeah? Main flow, okay? So another specific information is the flow of the program, yeah? What is the main flow that this program follows, right? Key parts, okay? For example, highlight to me the key parts of this code, yeah? Data flow, for example, what are the inputs to this program and what are the outputs that it generates, okay? And finally, integration, yeah? So how could this code be used in a real robotics setup, real robotics project, okay? Yeah, so this is a super prompt that I am leaving here in the ROSJECT in case that you want to use it as a template for your prompts, okay? And in my case, I'm going to use it right now also here. So let me copy and paste it to ChatGPT, and I'm going to use it as an initial template, but I'm going to modify a little bit of things, okay? Very few. So I'm going to tell ChatGPT, you are an expert in robotic software. In this case, ROS2, Gazebo, for example, and let's say perception, okay? Perception, for example, we can say OpenCV. Yeah, it's another technique, for example. I'm pretty sure that that Nico is using OpenCV. So we can see it here, right? So, for example, we can also include the OpenCV framework to provide more context to ChatGPT, okay? Then give me a concise but clear analysis of this code, right? Then I am interested in the purpose. What does this code do? In this case, I'm going to skip the ROS context, okay? Because we are already familiar with the context from other projects, from the contest itself, yeah? So we can easily get information about the topics being accessed here, okay? So I'm not going to ask ChatGPT about that, right? So let me remove here then line 2 about the context. I'm going to leave main flow. I'm interested to get information about the main flow. Also, I want to know the key parts of the code. And also, I would like to know the data flow. Yes, no. Yes, let me actually leave the data flow. What I'm going to remove is the integration, okay? So, one, I'm interested in main flow, key parts, and also the data flow, okay? And then, finally, down here, I'm going to paste the code. So let me select the whole code, copy it, and paste it here for ChatGPT. Okay, anything else that you think we should add to the prompt? I am reading you. Anything else that we could add? You can help me create this prompt. Any suggestion? Is it good like this? Shall we leave it like this? Yes? Federico says thumbs up. So, thumbs up. Let's send the prompt. Okay. Let's leave some time for ChatGPT to analyze. By the way, something that I have not commented is about this. So as you can see here, in this last week, ChatGPT has upgraded to GPT-5, okay, which is the newest model. So yeah, in theory it comes with many improvements. So yeah. Okay, then here we have the response from ChatGPT. All right, so let's have a quick read about this. So a single ROS2 node that navigates a mobile robot to a target post using odometry, then switches to vision-based line following, okay, as we predicted, using an onboard RGB camera. It publishes velocity commands and visualizes intermediate vision masks for debugging. This would sit in the local autonomy layer. First a simple go-to-post behavior, then a PD visual servo to track a floor line, white with yellow fallback, okay? Main flow, startup, it subscribes to certain topics. Stage 1, go to, yeah? Target X and E. So from odometry, compute distance and yaw error to the target. Drive forward with fixed linear speed, apply small heading corrections if angle error, okay? When distance is lower or equal than 0.7 meter, stop, lock, set navigation complete to true, and switch to vision mode. Okay, so very interesting. This is something that I didn't get on the first run of the code. So basically from this we learn that this code is basically doing the first part of the track without vision, okay? So it does an initial movement probably to get past the starting line, right? Let me mute this, yeah? So for this initial part of the track, from the starting point, it just moved forward for about 0.7 meters, yeah? Probably because in the first area, there is no line, right? Until it crosses this finish line or a starting line, yeah? The line starts here, okay? So what Nico is doing is to just set a fixed target, which is 0.7 meters, okay? And then when these initial 0.7 meters are reached, then it switches to vision mode in order to start detecting the lane track, okay? Very interesting. Then stage 2 is vision line following. So basically the camera thresholds white, primary, and yellow fallback in two trapezoidal ROIs, regions of interest, far and near. Okay, so do you remember those sections that we were seeing? Basically, they are different sections which are far and near. Let me run again the code very quickly here so that you understand what I am talking about. Do I have the terminals? Here are my terminals, so let me run the code again. Yep, there we go. So there we have the initial movement, and now it switches to vision mode, okay? And here we can see two polygons, right? So the lower polygon, this one which is switching between blue and red, it's like the near portion, and the upper polygon is the far portion, okay? So again, super interesting as well. Okay? Let me just mute the simulation. And yeah, let me just stop again the program. Compute the centroids. Set linear velocity to whatever, publish twist only while navigation complete is true. Okay, and a final stop condition. And here we have some key parts of the code. So the vision line follower node, the odometry callback. Okay, so before vision mode, simple navigate to pose. Yeah. The image callback, obviously, it's another key part. And here we have some more details about this image callback. Yeah. So builds two trapezoidal regions of internet. This is what we were commenting right now. Okay. It uses HSB thresholds for white and yellow fallback, okay? It has a PD control, okay? Also something very interesting. On pixel error, okay? Angular Z, linear X. If no detection, stop forward, set angular to search. And draw diagnostics and shows OpenCV windows. And here we have the data flow of the node, yeah? So as inputs, it has the odometry data and the camera data of the robot. Yeah. As processing, it has go to pose, vision, and as output, it produces basically command belt values, so twist messages, yeah, to basically send velocities to the robot, debug user interface, which it's what we were visualizing, okay, with multiple OpenCV windows, and finally some logs for vision and odometry status lines, okay? Some additional notes. So yeah, as you can see, this very quickly it helps us to get a pretty. In this case, it's a combination of high level with a bit of detail, okay? Because there's quite some detail here, yeah? But we have actually specified it to give us some information about the key parts, so it makes sense that we get this information additionally, okay? Yeah? Olexi says, it's better to attach a file. Yes, we could also have attached a file, okay? In my experience, actually I don't know if this is true or not, but in my experience, when I attach files, it takes a bit longer for ChatGPT to analyze it. I don't know, maybe it's just my perception and it's not true. But yes, so basically instead what Olexi is saying is that instead of copy-pasting the code directly here, like I have done, what you can do is to directly upload the file. Yeah. So for example, in this case, this is the file that I am interested, right? Simple driver. So I can download it, right? And then I can just pass directly the file here to ChatGPT like this, right? I can directly upload the file to ChatGPT instead of copy pasting the code. Yeah. Yeah, so this is perfectly fine, okay? In my case, I don't know why, probably just a perception of mine, but it usually takes a bit longer to when I do it like this. But yeah. Karim says, ask it some questions about improving performance. What's the performance limit reached speed-wise? Yes, so obviously now we can create some follow-up questions in order to improve the performance, right? But before that, I would like to move to step 2. Okay, let me go back to my notebook, which is get into details, okay? So once we have a general idea of the code, we can get more into details. So for example, what is the part that I am more interested in this code? Okay, let's say that for me, right now, the most interesting part is this image callback, right? It's the one that is in charge of the perception, the line detection, right? So I'm really interested on knowing more about this image callback. Then what I'm going to do is to ask a specific question about this function. For example, I'm going to use this ChatGPT prompt, which is one of the examples that I had here, yeah? Like step through this function line by line, explaining the purpose of each major statement, okay? So I'm going to copy this prompt, paste it to ChatGPT. So step through not this function, but I am going to specify the function, through the image callback function. Yeah, this is the name of the callback. So step through the image callback function line by line, explaining the purpose of each major statement. Okay, let's get into more detail and analyze better the image callback function. Okay. There it's thinking a little bit. This is taking a bit longer, so probably it's doing a much more in-depth analysis. There we go. Okay, So here we have a in-depth analysis of the code itself, okay? So now we are getting more into a lower level, okay? So far we have stayed more or less at a high level, okay? Understanding of the code, but now we are going on a lower level and analyzing the code itself, okay? So we can see here, get the image and basic geometry, for example, yes? Convert ROS sensor image OpenCV to BGR8 image. If conversion fails, logs and return, okay? Define two trapezoidal ROIs, far and near, okay? I can see exactly here where this is being defined, okay? Pick polygon corners that narrow at the top and widen at the bottom to capture line perspective, okay? So for the near perspective, it's going to be wider, and for the far perspective, for the far polygon, it's going to be more narrow, which it makes perfect sense, right? Then build binary masks and apply them, okay? Rasterize the polygons into 8-bit max, 0, okay, etc., etc. I'm not going to go into all the details of this, but you can see that now we are getting into much more detail about the code, okay? And we could even go another step further, okay? So let's say that I'm specifically interested into some specific lines that I don't understand. I don't know. For example, this line, okay? Here I am doing this bridge of image message to CB2, okay? But I don't understand the purpose of this. So convert ROS sensor image to OpenCV BGR image. Yeah, this is what's going on here, but let's say that I don't understand exactly what's going on here, okay? So I'm going to ask a specific question about this because I want to understand it better. Why is necessary to convert the ROS sensor image to OpenCV BGR image? Also, what is BGR8, for example? More follow-up questions, okay? So while getting at a lower level, it is likely that there are things that you are not going to understand, okay? So you have to treat ChatGPT as a conversation, okay? And ask follow-up questions. So, okay, wait. I need to understand this better before moving forward, okay? And I don't know why is it necessary to convert the ROS sensor image to OpenCV BGR8 image? Also, what is BGR8, okay? I need more information before I can continue, okay? And these are questions that you can do to ChatGPT in order to understand everything step by step, okay? Then, for example, why to convert sensor image to OpenCV image? In ROS, sensor image is just a message container. It has metadata like height, width, encoding step, and raw byte data in a specific format, okay? OpenCV, on the other hand, works with NumPy ND array images where pixel data is already in an accessible array form. So to run color conversions, masking, thresholding, drawing, etc. in OpenCV, you need the image in OpenCV's native format. Okay. And CV Bridge handles this transformation, reads the ROS message, decodes the raw byte data according to the encoding, and outputs an NumPy array in the specified color format, BGR in this case. Okay, so this makes more sense, yeah, because I need to actually do some processing with the images, yeah. Originally, the image is in ROS format, okay, because I am running a ROS-based simulation, but for being able to properly process these images, I need to convert them to OpenCV format, which is the framework that I am using for perception, right? So I have to convert, basically this means converting the image from ROS format to OpenCV format, and CV Bridge is in charge of doing this transformation, okay? And what is BGR? BGR, its pixel channels are ordered blue, green, red. OpenCV default ordering, unlike RGB, use it in most systems, okay? Each channel uses 8 bits per pixel, etc. Okay, some examples. So in short, okay, We convert BGR8 so OpenCV functions can be used directly without worrying about ROS image encoding formats. BGR8 is chosen because OpenCV expects disordering and bit depth for color images. Okay, and even we can do more follow-up questions for more deep understanding. Okay, but basically this is the general pipeline that you would follow when analyzing code. Okay, so you start on the high level. Okay, trying to get a full a general understanding, okay, a big picture of the code you want to analyze, and then from there you start getting more specific and going into lower layers to get more specific information about the parts that you are interested in. Okay? Yeah? And even this is something that I was doing during my testing for preparing the class, and I thought it was pretty interesting. So, for example, we can try to run it here if you want. This is just for creating an as-see diagram, okay? So, for example, draw an as-see diagram of the main flow of the whole ROS2 node based on this code, okay? This is for adding some visual understanding, okay? This is something that for some people is very helpful, okay? And I tried this prompt while testing, and the output was very interesting. So let me try to run it again now, because it was very interesting actually. Okay, so this is the diagram that is generating for this code. So we have the vision line follower, which is the main node. Here we have the subscribers, which are the image route, the camera and the odometry, and the publisher is FastBot command bell, okay? Then the robot, basically the code has two states, which are navigation complete, false. In this case, it's going to use pause navigation, okay? So basically this is for where there is no line to be detected, okay? And if navigation complete flag is set to true, then it's going to use the vision, the perception-based module, okay? And here we have also some graphs that are pretty interesting, yeah? So we have a callback for the odometry, yeah, which does all these, and we have a callback for the image, which is in charge of doing the vision processing, okay? And here we can see some details. Okay, including if the centroid exists, this is going to happen. If not, no line, then this is going to happen. Okay? Yeah. So, yeah, for me it was very interesting, this analysis with the as-see diagram, because it gives you a graphical aid, yeah, help in order to better understand what is the flow of the code. Okay, but just something that I wanted to quickly show here. Okay. Then, yeah, so this would be basically an overall example of how you should be analyzing code that you are unfamiliar with. Okay. So we have been using so far Nico's code. Then I'm going to switch now because we are running out of time. Actually, we are already out of time. So let me switch already to Rajesh code, and we are going to have a look now at Rajesh code. So let me update that code, not here, but here. His code real quick. It's this one. I have created like a specific workspace for Rajesh work. I like Karim saying, I like to ask for diagrams in SVG or GraphML format. Yeah, you can totally do that. Okay, so ChatGPT is able to create those kind of diagrams for sure. Okay, then let me now prepare Rajesh code very quickly. So basically what I need to do is to create the workspace. Let me create it here, mkdir ROS to workspace rush, for example. There we go, and then Here is Rajesh code, which I'm going to move inside the into ROS to workspace Rush. There we go. I really encourage you to stay because yes, Rajesh code is really, really cool. Okay, so yeah, let me remove this. Then one thing I know that I need to execute because of my previous tests is to execute the script install monitoring dependencies. All right. So let me run this script. There we go. And something else I need to actually change, okay, is something in the code. Let me try to find it. It's just a path, okay, just something very stupid, but I know I need to change it, so let me do it already. So because I have changed basically the name of the workspace to ROS to workspace Rush, okay, so I need to change a specific path that is in this code. Let me look for it like this, ROS to, here it is, okay? So ROS to workspace Rush, there we go. And then let me just compile his code. So rm-rf build install lock and colcon build, there we go. So I think we are good to go. Then install setup.bash, and the command is again the same, ROS to launch, FastBot Racing, and start racing, okay? All right, so let me prepare the simulation here one more time. I'm going to mute it, and let's execute Rajesh code. There we go. Okay, so the robot starts moving, and it starts apparently also following the line. All right, we can see it's doing some corrections, and let me move back here to the terminal, because the first thing you can see, I think this is amazing, is that his code is generating live commentary of the race, okay? So while the robot is progressing through the track, we can see actually many things, the percentage of the circuit that has been completed, right? The distance that has been completed, and even some commentators and their comments about how the race is going. So this is actually incredible. But that's not the most interesting thing. There are many other things that Rajesh included into his project. Here, the robot almost went outside the track, but it's continuing, okay? For example, he provides a web page to actually follow the race live, okay? Let me click here. This is the link to go to that web page. Can I get the link? There we go. Okay, let me go back to the simulation here, because so there we have the robot. It's approaching the line, and here in the web page we can see exactly where the robot is, in which part of the track it is, as you can see, and even the lap time, the current speed of the robot. Yeah. So it's actually amazing work and super cool project, okay? And it has many more things, yeah? So he has not only built this web page to be able to follow live the class and analyze the information, but also it has another web page that we can use in order to analyze all the sessions. Yeah, we can analyze all the different sessions, the laps, the time of each lap. Okay, we can see if the robot completed or not the lap. Yeah, so actually incredible work, and even though it was not the fastest, unfortunately, I really wanted to show his work for this because it's really impressive. Okay, it's really impressive with many additions, web pages in order to get additional data. So and even the detail of the live commentary, which I find really interesting and really nice. So yeah, I want to personally congratulate Rajesh for creating this such an incredible job. All right, and I hope that we can see you also in the upcoming challenges. Okay, I'm going to be so Ricardo already announced more challenges related to the FastBot Racing Contest that are going to come really soon. So I'm going to also do a quick reminder about this, right? Right after before finishing the class. Okay, but yeah, really impressive work by Rajesh with all this. And I want to also analyze his code because yeah, so just running this looks very impressive, but actually if we go to the code, okay, this is the main code that Rajesh is running as the main controller, okay? And actually this code, for example, has (1,400 lines, okay? So this code in specific is huge, okay? And this is not even all the code that Rajesh is using for his implementation. So actually we can have a look at the launch file, and we are going to see that he's actually running other nodes as well. Yeah, so this is the controller, which is the main node, but there are others, right? Like the wall forward node, monitoring node, etc. By just the control node has 1,400 lines of code. Okay, so if I wanted to analyze this code by myself, I can tell you it would take me some time, okay? So instead of doing that, what I'm going to do is to again ask ChatGPT to analyze this code, okay? So let me do that. In this case, I'm going to try downloading it, okay, as Alexi suggested. So I'm going to download it here into my local computer. And I'm going to paste, I'm going to change my prompt also now. And I want to create a more simple prompt. So let me go back to my project, go back to my, okay. Yeah, so let me, for example, try one of the prompts that we have here in section number 3, which is to use target analysis prompt. So for example, for the high level overview, okay? Then I'm going to use this prompt as a template, okay? And let me come here to ChatGPT. I'm going to actually create a new chat. And, okay, so explain what this code does. I don't need to specify in plain English. Explain what this code does. Explain what this code does. Yeah, for example, as if I'm new to this robotic project, okay? Then we are going to provide some context, okay? As some of you were providing, for example, so context, it's a ROS-based code, yeah? Use it for helping a robot complete a full lap to a racing track, for example, okay? Is the ROS2-based code used for helping a robot complete a lap to a racing track, okay? And I'm going to upload here the code, for example, Vision Hybrid Race, open. Here I'm loading the code. Anything else that you think I should add? Karim, Alexi, anything else that you think I could add? Okay, let's try this prompt and let's see what we get. So now I'm getting a beginner-friendly explanation, okay? Purpose, what is this code for? This ROS2 node controls a race robot so it can complete laps around a racing track quickly and safely. It blends two driving methods, waypoint following and vision-based steering, yeah? The waypoint following is using a pre-recorded set of points around the track, using the camera to detect the track surface. Very interesting, okay? And it continuously decides which method to trust more, waypoints or vision, depending on track section, curbs, tunnels, or if vision fails, yeah? Here I have a more detailed description of how it runs, yeah? Big picture flow. So startup, main control loop, lap tracking, for example, some key parts, again, of the code, yeah? Main function classes, vision hybrid, ODOM callback, scan callback, image callback, yeah? So I am getting information about specific callbacks. For example, the image callback, again, is used to process camera feed, yeah? It converts ROS image to OpenCV, uses HSV color thresholds to find the track, okay? This is a similar method, actually, to what we explained in previous open classes, yeah? To use HSV threshold to filter the track, okay? So in the previous example, we saw detecting the lane, right, in the middle of the track. Here we are actually detecting the track itself. Yeah? Calculate where the track center is, centroid error, and estimate confidence in vision detection. Yeah? And other functions that are interesting of this code. Yeah? Here we have the data flow. Yeah? So waypoints, the inputs are the waypoints from a preloaded track file in PKL format, the odometry data, LiDAR data, and camera data. Yeah? Here we have more details about the processing of all this data, and the final output is velocity commands, obviously, to move the robot, telemetry, which is being outputted to a topic, for example, this control telemetry, very interesting, and also to a JSON file, yeah, and lap time logs in console, okay? Here, for example, ChatGPT is even suggesting to draw a simplified diagram showing how all these inputs, decision, and outputs connect during a lap. Yeah, let's tell him yes. Yes. Draw me a simplified diagram, for example. Let's see what ChatGPT gives us. Yeah, so here I have an ASCII formatted diagram, again, with the main node, which is Vision Hybrid Race, subscriptions to ODOM, scan, camera, yeah? Waypoints, playback loop, yeah? So this is the control part, yeah, to find closest waypoint ahead, compute curvature ahead, decide control mode, straight is vision led, curve is waypoint led, okay? So it seems like if the robot is in a straight line, it's going to switch to the vision-based control, yeah? And when the robot enters a curve, it's going to use waypoint-based navigation, okay? Yeah, and the fallback is waypoints, okay? For example, when there is poor or no vision, okay? So very interesting also this switching on methodology between a straight portion of the track, curves in the track, okay? And this is the summarized logic of a full lap, yeah? Start on first waypoint. Detect finish line via waypoint window plus near the start pause. Records lap time, max speed, wall warnings, continuous mode, jump to closest waypoint and keep going. Single lap mode, stopper, print stat. Okay. Yeah? So here with within a few minutes, I am able to get an idea, a general idea of what the code does, the most important parts of the code, and where I might be more interested into looking at, okay? Which is something that otherwise, if I would have to analyze all these more than 1,000 lines of code by myself, it would have taken me much longer than this, okay? And so with the help of ChatGPT, I can get a general idea of the whole code within a few minutes, and then from there start going deeper into the details that I am more interested in. Okay, I want to now get more information about this playback loop. What's going on here? Show me the code. What is happening? Okay, yeah, but always start on a high level or on the big picture. Okay, so yeah, there are many more things that Rajesh created, as you can see, many different codes. Yeah, so amazing work, the one that he did, even including all these web pages for visualization. So yeah, again, my congratulations, and yeah, I have to be thankful for having ChatGPT, so that I have been able to easily kind of understand what Rajesh did and have a good idea of his code within a few minutes, because otherwise it would have been much more complicated. All right, so yeah, then if there are no more comments, no more questions, I think I'm going to leave it here. I'm already 23 minutes past the expected class time, as always. So yeah, basically I just want to finish with a comment that this robot racing contest that has just happened and that our participants have been creating code for is not the end, okay? So Ricardo already presented a new challenge last week in the winner ceremony, and I just want to remind you that we are going to be launching, actually you can already get into this challenge. There's going to be more information about it soon, but in this new challenge, you are going to be competing live with other robots. Okay, so you can see in this example ROSJECT, you are alone. Yeah, your robot is alone in the environment in this racing track. Okay, in the new ROSJECT, which by the way I have shared the link here, you are going to be alongside other robots. Okay, you can see also, let me share here an animation. There you go. Yes. So you are going to have to prepare your algorithm, yeah, to run with other robots in the track. So you have to be able to surpass them, to avoid them, whatever. Okay. Then there are going to be different levels about this new challenge. So, for example, the first 5, let me show it here. Yeah, so the first 5 ranked participants are going to be on a single contest. Okay, they are going to race against each other, but there is going to be option for any other participants, even the ones that did not finish, to prepare their codes and compete in a secondary league. Okay, and even for people who has not participated yet in these challenges. Okay, so just want to remind you about this new challenge that is coming soon, and you have the link for this new challenge to get the ROSJECT related to this new challenge also here. Yeah, you just have to copy the link and share it to your browser. So yeah, basically I'm going to leave it here. Karim say, thank you, well-developed course with concrete examples. Thank you very much, Karim. Thank you very much. I hope that you have enjoyed the class. So yeah, for everyone else, thanks a lot for being here with me today for this class. I hope that you've been able to get some interesting knowledge, that you can start using more ChatGPT for analyzing code and for getting familiar with new code, and optimize your time, basically, right? So yeah, thanks again, everybody, for coming. See you soon in the next class, and as always, until then, keep pushing your ROS learning. Bye-bye.